So 3.3 is really just a little section here, and it's an introduction to polynomials. We're going to be dealing with polynomials as we finish up our chapter 3 as we add and subtract polynomials and then multiply and divide polynomials. So we should know what polynomials are. We're also going to deal with polynomials in chapter 4 as we factor polynomials. And so this one gives us just an introduction to what the heck we're talking about. And actually what we're talking about are just expressions, and we've talked about these before. They're expressions made up of a number of terms. And so as a review, a term is a number or the product of a number and one or more variables, and that would be letters. And so we can have exponents on those variables, and we can have coefficients on those variables as well, or coefficients of the terms. And we remember that the sign goes with the term. So as an example here, if I have negative 2x squared, I would have the exponent, you know all this, we have the variable, and we have the coefficient. And the sign goes with the term. So the coefficient here would be a negative 2. So in these ones, this is an example of a polynomial, and we could circle the terms. And again, the sign goes with the term. If there's nothing there, it's a positive. So those would be the three terms in that polynomial. So a polynomial is a really general term. It's a general term for an algebraic expression with one or more terms. So it can have any number of terms, and we'll talk about the different names for specific kinds of polynomials at the bottom of the page. The key thing about classifying a polynomial is that we don't want to deal with any letters in the bottom of a fraction. And so we're going to start off by, experimenting with this definition of a polynomial a little bit and knowing that polynomials are made up of terms. We're going to take a look at these examples and decide, is it a polynomial? And if it is, then we want to circle the terms and list the coefficients. And so A off the top here, it is a polynomial, it's an expression, and it's made up of three different terms. And we've already practiced circling terms even in other chapters. Whoops. And the sign goes with the term, and the sign also goes with that coefficient. So if I listed the coefficients of this polynomial, it'd be a positive 2, a positive 1, because that's what the coefficient on that x is there, and a positive 1. For B, if we take a look at this one, it is a polynomial. I could circle my terms and list my coefficients. That's a positive 3, a negative 2, and a positive 5. You don't have to write the positives in, but you absolutely need to write the negatives in. And so I put all the positives and negatives in here. For C, C is this exception. You'll actually find a mistake in my key on this. This is the problem thing that we have an x down below. So that makes it not classified as a polynomial. And if it's not a polynomial, then we're not going to need to circle the terms and list the coefficients. The one up the top here is here as a bit of an oddball. Technically, it is a polynomial. There's only one term in it, which would make it a monomial, and that classification's coming up. The coefficient is a positive 5. D, the y again is down below, which makes it a problem, not a polynomial. And E, it is a polynomial. The problem, or the thing about this one that might catch your eye is that you have a fraction, but that fraction is a coefficient. It doesn't have the x down below. It doesn't have the variable in the denominator. So it can have numerators and denominators, just not the variable in the denominator. So circling the terms, we'd have those three. And listing the coefficients, we have a positive 4, a negative 2/3, a fractional coefficient, and that positive 3. So the specific language behind polynomials is that you can classify them by their number of terms. So monomials, like that 5x squared that I said, just have one term in simplest form. A binomial has two terms, so that just might be a x plus 2, and a trinomial has three terms in simplest form. And many of the examples up above on this page are trinomials. And so you might have an x squared plus 2x plus 1 as your trinomial. Anything more, if you can have four terms, but that would just be a general polynomial. So these are all polynomials, but more specifically, we can classify them by their number of terms. As we continue to talk about polynomials, the other thing that we can do with polynomials is say what degree the polynomial is. And what we're talking about this is the highest power, the highest exponent that you can see in any term. And so the degree of the polynomial is something that we can state, and then we can also arrange it in descending order. And this is a convention in math that's how you give your answer. So oftentimes we alphabetize our terms or what have you, and we always write them in descending order. They're not technically wrong if they're not in descending order, but it is a convention that's worth noting. So if I take a look at A, and I'm playing with these two ideas of what degree is it, and writing it in descending order. So the highest exponent that I can see there is a 3, so that makes the polynomial to the 3rd degree. And again, this is different than the number of terms. We're talking about the exponent here. And if I were to rewrite this in descending order, I would start with the largest exponent that I see and move down to the smallest exponent that I see. I'm just going to leave a little space there. I'm going to come back to this example. So the next one, we're going to do B next. So B has something about it that's invisible. And we've seen this in exponent laws, so I don't think it's going to be a shocker to you that there's actually a 1 on that x there. So that would make this to the 1st degree. And I can't write it in descending order because it's just one thing, right? That brings me back to the missing term over here. And so we have the 3rd degree, the 2nd degree. If we were to step it down, we could have the 1 degree, right? And there isn't anything there. I'm just going to pin a placeholder in. So I added that to the question. And that's planting a seed for where we're going to go in the next section when we add and subtract things. But this then brings us on to the last thing. So take a look at C here. Remember how I said that 1s and 0s are tricky things? If I were to take a look at the example in C, 7 has a whole lot of invisible things going on. If we remember back to our exponent laws, it could be to the 0 degree. Anything to the 0 is 1. And so if we were again to go back to that first example and step down one step at a time, so 2nd, 3rd, 2nd, 1st, 0, all of this is invisible. So there definitely are some invisible things here. You know, these, I was just going to switch colors. So this 1 is invisible and all of that is invisible, as is this whole term. It's missing. And so that would make this example here to the 0 degree. And again, you can't write it in descending order because it's only one term. It's a monomial. So D, if I move on to that one, the highest exponent that I can see is a 6. So that would make it to the 6th degree. And writing it in descending order, I'd have a 2x to the 6, a positive 3x cubed, and a minus 1. The next one's down here. So E, the highest exponent I can see is a 5, so that makes it to the 5th degree. And writing it in descending order, I'd have a negative 4x to the 5, a positive 5x to the 4, and a positive 7. The last one here, the highest exponent that I can see is an 8, so it would have a, say it's the 8th degree. And writing it in descending order would give me a 6x to the 8, a positive 9x to the 4th, and a positive 4x to the cubed. We're almost done, just a couple more minutes. I'm not sure if you heard the dog go nuts in this video. Sorry for that. It's my 3rd take on it today, so I'm going to stick with it. Barking dog and all. The last part here is evaluating polynomials, and we've done this. Last time we saw this, we were evaluating expressions, but now we've been introduced to these polynomials. We're going to finish up this page with the last 2 examples here. So what we're going to do is sub in with brackets and evaluate these things. So I rewrite my expression, plugging a 2 in where I see an x. And then I'm going to follow order of operations. So I'm going to start with the exponent. So that'd be 3 and an 8 and 2 squared. And I'm just recopying the rest. I'll move on to the multiplication next. And so that would give me a 24 out the front, -8, -8, and a +1. So doing the adding and subtracting leaves me with an evaluation of this polynomial at 9. The next one, you knew it was coming. We've got a negative value to sub in. So this is when the subbing in with brackets made all the difference in the world. And it's why we developed that habit in the first place. So I rewrite my expression, subbing a -3 in where I see the x. The next step that I'm going to do is just the exponents. Watch your negative signs. Recopy anything that's not just doing exponents. Then I do the multiplication. And I'd finish it up giving the solution or the evaluated answer here of -142.